Alrighty, guys. So like I said, the discussion post for this week is on God Committee. And of course, you had your initial post, which was due yesterday at midnight. And again, this was a very short, podcast because we were not listening to the whole entire episode. We were just listening to this, I think they called it part one or act one or something like that. And it was kind of neat to see, how this doctor developed the first dialysis machine in Seattle. And then, they had to choose a limited number of people who could participate, for the treatment. And it was kind of interesting to see how they narrowed down their choices, how they selected the patients who would be getting the treatment. And even though they tried their best to not let any of their personal biases come in, obviously you see that, the patients that they chose, you did have a bias in those patients. And so obviously their efforts, even though they had good intentions, didn't go as planned. And, so it was kind of interesting. I know when the first vaccines for COVID came out, they again went through that hierarchy, right? With the first line workers, the doctors, nurses, and all of them were ahead in receiving them. And then, they went with the sensitive, high risk, elderly people. And then, they kind of trickled down to others who could come down. So it was kind of neat, again, because we went through that same idea of, okay, our vaccines are limited. So how do we go about giving these to people? And, there are still so many countries that have maybe 2 or 3% vaccination rate because, they just don't have access to vaccines like we do. And, again, it comes down to, okay, so how do we choose people who get the vaccine? So, think about this, like I said, in a more, you're choosing a sample from your population. So what process is involved? So you can see I have questions based on just to kind of guide you on how you would do that. So that was all of you yesterday. And then today, and of course, you're doing this as videos on Flipgrid. And then tomorrow you are responding to your peer reply post. So just again, please make sure you don't miss that deadline. Get those peer reply posts in. And then that will be the end for the discussion post, for this entire class. So this is the last one you guys are working on. And then, as I mentioned, the activity that we're doing is based on binomial distribution. And so I just picked a simple experiment because I want you to understand the concept and not worry so much about, what experiment we chose. So this is just a simple, flipping a coin and understanding the idea of how a binomial experiment, and then based on that, how a binomial probability distribution would end up looking like. So for a binomial experiment, you have these 4 requirements. You have to have a fixed number of trials. So you will see in your instructions down here that I'm asking you, sorry about that, guys. I am asking you to flip your coin, 10 times. So that is going to be your trials, right? How many times do you flip that coin? So a limited or a fixed number of trials. We are saying for step requirement 2 that each trial can only have 2 outcomes or outcomes that can be reduced to 2 outcomes. So you can think of them as success or failure. So, again, flipping a coin kind of helps you with that. If you're looking for tails, then the tail becomes your success. And if you land on a head, that becomes your failure, or vice versa. If you're looking for heads, then that's a success. If it lands on a tail, it's a failure. You can actually do this even with something like rolling a die, right? So you can say, okay, I want to land on a 3. So if my die lands on a 3, that's a success. If it lands on any of the other numbers, right? So if we use a 6-headed die, so if it lands on 1, 2, 4, 5, 6, well, all of those are failures. So that's what they mean, that if you can reduce an outcome to 2 outcomes, one of them is success, the other is failure. One of the other things we use often with probability examples is drawing a card, from a deck of cards. So again, let's say you wanted to go with, I don't know, Jack of Spades. So if you get the Jack of Spades, that's your success, and all the remaining cards are failure, right? So you can break down your experiment into two outcomes, that's what we're looking for in a binomial experiment. The other one says the outcomes of each trial must be independent of each other. So what that means is if I flip a coin one time, it should have no effect when I flip my coin the other times, right? So the best way to explain this would be with a deck of cards again, because, think about a deck of cards. We pull that jack of spades out, and if you keep it outside and you don't put it back into your deck, then actually each of your trials are not going to be independent, because now instead of having 52 cards in your deck, you're only going to have 51, right? Because you set that one card out. So that means your outcome will change if you draw another card. But if you were to, get that jack of spades, you make a note of it in your notebook or something, and then you put the card back into the deck, then your trials are independent, because now you have the full deck again and you choose a card again, your trials will be independent. So that's what we're looking for in a binomial experiment. And the last one says the probability of success has to remain the same for each trial. So, again, going with the deck of cards, if you pick one card out of 52, your probability is going to be 1 out of 52. If you left that one card outside, your probability changes from 1 out of 52 to 1 out of 51. So you can see how that probability changes. And that's what the last part is saying. It has to remain the same for each trial. So that's why it's very crucial. If this were a deck of cards, we bring that card back into our deck. So those are the 4 things you are always looking for when you're working with a binomial experiment. So you will see questions in your homework where they ask you if this can qualify as a binomial experiment or not, if this is a binomial probability or not, so they'll have some of those questions just to get that critical thinking type of questions in to see, okay, so are you comfortable with this concept of what a binomial experiment and a binomial probability distribution is? So you can kind of see some examples that I've talked about, but some other that I've mentioned in here, like a multiple choice question. If you have 4 or 5 choices, well, one of them is the right answer. The rest of them are going to be wrong answers. So same thing, you can think of the right answer as being the success and all the wrong answers being as failure. So again, those 2 outcomes that we were looking for. So, read through that. I've again included some videos just to help you understand probabilities and a binomial distribution itself. So once you start working through the binomial distribution, you will see that we do actually use the binomial distribution table to kind of come up with some of these probabilities. So this is, what a normal binomial probability distribution will look like. We also use formulas to calculate our probabilities, but this was just to show you what a table looks like. And you will actually be using this table later on in this experiment. So for this one, I am saying you need a fair coin. And the idea of a fair coin is, it should have equal chances of landing on a head or a tail, because, sometimes you have those trick coins where there's a little bit more weight on one side. So it keeps landing, only on that one side. So we just want, a regular fair coin. So if you guys actually have coin at home, you can use that. If you are someone like me, you will not find money anywhere near me. I carry cards. I never carry money on me. That was more of a mom thing than my thing. And so if you don't have a coin like I don't, you can see I have included a virtual coin flipper here that you can use. And again, my favorite website, random.org. So this is based out of random.org. So it's a coin flipper. Now they're by default set up to do 2 coins. We don't need 2 coins. You can just do it to 1 coin and, select the type of coin you want. So, if you wanted to pick something, I don't know, let's go with the Australian dollar. So we can do that. I would say before you start doing your experiment, flip that coin a couple times so you know what a head and what a tail on this coin looks like. Because, if that's not a coin you're familiar with, then you want to make sure you know what the head and the tail looks like. So they actually have Queen Elizabeth II, from Britain as their sovereign, because, Australia is part of one of those Commonwealth countries, so they actually do have Queen Elizabeth on their coin. So that's the heads. And then you can, of course, see, I'm not able to make out what the design on the tail side is, if we ever get there, but I think it might be partially the,
kangaroos.
yeah, I think it's kangaroos, and I'm seeing the part of the Australian, country's map over here. So you can kind of see, okay, so that's the difference between the head or the tail. Obviously you can always go back and pick a quarter. I think they have a quarter and a dollar. Okay, buddy, let's go back. Just scroll down to the bottom and you'll find US coins. I guess we'll pick Connecticut just for now. So you can see, this would be a more familiar coin. Now, the other thing you want to keep in mind when you are doing these virtual flips, because, it can land on the same side. So look at the timestamp, because the timestamp will change. And, obviously it's going to be more of this part over here that will change. So that's how you know your coin has flipped. So you can see now we're at 1833.15. 1833.19. So, even though we landed on tails both times, our timestamp changed. So that's how we know our coin has flipped. So that's kind of what you want to do when you're doing this. Obviously you guys can get creative. If you want to do just one single coin flip, since you're doing this 10 times, you can just pick 10 coins and flip your coin, and then, record the different heads and tails you have. So use the coin flipper, like I said, if you don't have an actual coin. Now you are flipping the coin 10 times, recording the outcomes. Did you get a head or a tail? And then you repeat this experiment 3 times. So you will see in this spreadsheet that I have over here, I've already created the grids for you guys to record your, findings. And then we're basically saying, let your binomial random variable X represent the number of heads. N will represent the independent number of trials we performed. P, of course, will denote the probability for success for each trial. So I've actually made a copy of the template over here. So let me share this link with you so you guys can go ahead. I want to make sure I've given you editing rights here. There we go. So through your chat. Okay, Alexis, I saw your message. That would be fine. So through the chat, guys, you will see the link for this template come through. And I have shown you 2 different, experiments that I did. Google also has a coin flipper if you just, Google coin flipper, but I did not like the results I got from it. I tried it several different times, and you can see the 3 experiments that I ended up recording, because I just kept getting 5 heads and 5 tails in the multiple experiments I did. So that's why I abandoned the Google search, coin flipper, and I went with random.org, because at least it gave me 3 different, values. So what you are doing here is you are recording the number of heads, because that's what I'm telling you, that your binomial random variable represents the number of heads, and as I mentioned is the number of trials, and P will denote the probability. So you will start by recording your coin flips, how many heads and tails you get. And I've just kind of walked you through, make sure you enter your name in the box. You've got my example to look at. And then on the second worksheet of this, template is where I will show you how we can come up with the binomial probability distribution calculations, using the formula. So let's go ahead and start out with your coin flipper. So, just pick one of these grids, put your name in there, and then you can start doing your coin flips and start recording how many tails and heads you are coming up with. And I hope that we get a good variety, Because remember, since you are doing 10 trials in one experiment, you can go anywhere from all the 10 times your coin landing on tails, which means you can have 0 heads, and you can go all the way to all 10 coin flips, giving you 10 heads, right? So remember, you can have the number of heads going anywhere from 0 to 10 with this experiment that we are doing over here. But let's see what you guys come up with as your number of heads. So I'll give you guys a couple minutes here to go ahead and start taking care of your coin flips. If you want to use the random.org coin flipper, go ahead and do that. You don't have to rush and find a coin. So just pick one of those boxes, go ahead, put your name. I think there should be enough spaces in here for all of you to claim a box, I guess. All right, I see Grace's name is already up there. That's awesome. Faith, okay. Very nice. Okay, I see Brooke. Ben, okay, very good. Samuel, all right. And since you guys are already doing the experiment, I would say, keep the experiment that you are doing, and you can just copy and paste it to the template when you guys are submitting this assignment for Saturday. So you don't have to start all over again. Just use the experiment you are doing today in class and build up from there as you move forward. Okay, Hillary, I see your name in there. Cody, all right, very nice. And sometimes it can take a couple seconds when you guys type in your names and start working till when I see it at my end. So I'll keep scrolling up and down to make sure I can make sure all of you are in here. And Grace, I like that you got 6 on the first experiment. So we're at least seeing a little bit of a variety of numbers. Very nice, Ben. Looks like you had 2 heads on your first experiment. So again, good to see some different numbers coming in there. And one thing I will tell you guys, if you, oh wow, Cody, you had 8 on that first experiment. That's amazing. If you try and make up your heads and tails, you will notice that your probabilities will not come out to be right. Because, when we make up numbers, your probabilities will usually come out to be pretty wonky. So you don't want to really make up the heads and tails, just do the 10 coin flips at the same time. And then that's the easiest way to get your 10 trials in one experiment done. All right, Sky, I see your name at the bottom there, and you got 4 heads on that first one. That's good. One semester when we did this experiment, majority of the students had 5. I mean, I think almost everybody got at least a couple 5s or at least 1 5 in their heads. And, we just did not have much variety. That one semester. It was so weird how everybody kept landing, just 5 heads, 5 heads, 5 heads. So I'm really happy to see you guys at least coming up with some different numbers. Grace, I see you have a 7 in there too. That looks good. Okay, Victoria, let me see. I will stop sharing my screen. And if you would try, because maybe if I stop sharing my screen, it will let you work on your screen and not keep bringing you back to Zoom. And let me know if that works for you or not. Alrighty, very nice. Okay, Brooke, you had 5 heads on that first one. Faith, you've got 5 and 6 in there. That looks good. Then you've got 2, 5, I guess 7. Okay, let's see. Samuel, you have 6 and 4 already. Cody, you have 8, 6, and 4. That's good. And then let's see. Sky, you have 4, 6, and 4. So at least a little bit better. There is still some repetition, but at least we are seeing some smaller numbers, some larger numbers. And I think 8 is something we don't see very often. So I'm kind of glad that, we've got some of those upper numbers in there. There's a 7, there's an 8. So at least we have a little bit of variety on our number of heads. So I'll give your classmates just maybe another minute to finish their experiments. Most of you are done. Okay, Victoria, I see you in there. So I'm glad as I stopped sharing, you were able to come in and start working on this. So that's good. Okay, Faith, looks like you got 565. Brooke, you had 563. So I'm seeing quite a few sixes in your outcomes here. Alrighty, so as you guys are finishing up and getting your number of heads, and I'm just gonna let Victoria finish because I'm afraid if I share my screen, it may not let her finish typing her answers in there. But in the meantime, if you guys, those of you who are done with your 3 experiments, if you go to the second worksheet, just at the bottom where you will see it says probability, binomial probability distribution. Okay, Alexis, you're also trying to put your answers in. Okay, your name didn't show up on my list here though. Let's see if I can go back and find you somewhere. So like I was telling you, go to that second tab, the second worksheet on this file where it says binomial probability distribution. Again, pick a grid for yourself and then just bring in the number of heads you have. So you can see how I had 3, 4, and 5 and I brought that in on that very first grid. So at least go ahead and bring in your number of heads. And then, we can start kind of looking at how to use the formula to calculate our binomial probability distribution. And then, we can check those against the binomial distribution table that I showed you, that little PDF file. And that way we know, if we're on track or if we miscalculated anything. And I'm just waiting for the last of you to finish typing in your outcomes. Alexis, for some reason, I'm not seeing your name on that worksheet at all. I'm not sure if it's just a connection thing that's happening. Okay, so I'm going to go ahead and share my screen here, guys, just so I can show you that second worksheet on our template here. So this is what it looks like, and you can see right here in the left-hand side corner, I have the grid that I created for myself. So I had 3, 4, and 5 heads. So yeah, Grace, I see you're already in there. Faith, Samuel, Brooke, Sky, Cody, all righty. Hopefully there are enough boxes for all of you here. So that's 8, 9, 10, 11. And I think, yeah, that should be exactly for all of you here. Okay, so let's talk about how to calculate this binomial probability distribution. So you will see, of course, I have the little, the name just went out of my head. Well, the definition for what these variables are. So n represents the number of trials. And of course, remember in each experiment, you are doing 10 trials. So that n value will be 10. And you can see that in my box over here, how I've listed those. Now, the probability of success for each trial, I have listed at 0.5. Can anybody tell me how we came up with that 0.5 as the probability of success here? Because, right now I'm giving that to you, but otherwise you will need to find out on your own, right?
Isn't it just because there's a 50% chance of success?
Yeah, very nice. Very true. Grace, you were going to say something?
That's what I was going to say.
Yeah, so remember in this experiment, what's happening is you have two outcomes, right? Your coin can land on a head or a tail. So since you have two outcomes and one of them is a head, that's why you've come up with 1 out of 2. So basically, you have a total of, and I guess I'm going to write it over here. You have a total of 2 outcomes. Out of that, we are only interested in when we land on a head. So, it comes out to be a fraction of 1/2, which of course comes out to be 0.5. So that's where I'm coming up with that 0.5. If this was a deck of cards, your probability would have been, 1 out of 52. Or if you were rolling a dice, this would be 1 out of 6. So depending on what experiment and, what, I guess, object or what thing you are looking at, those probabilities are going to change. So, because we picked a coin flip and you can only land on a head or a tail, of course, we're ignoring the fact that the coin could actually land on its side. So we're just looking at, you have 2 outcomes and we're looking at 1 out of the 2 outcomes. So that's where that 1/2 comes from. All righty, wonderful. Good job, guys. Alexis, you can do that, but what I would say is if you're unable to type it on the document, I would say record your answer so that way when you turn in the assignment, you don't have to go back and redo the experiment all over again, and you can still participate in the calculations with us. And so send me the answers for your calculations through the chat. But for your heads and tails, don't worry about it. You don't have to send that through the chat. I'm not sure why you're unable to access this document. That's kind of interesting because, as you can see, your classmates were able to get in. So I'm not sure if it's a computer issue, internet issue, what's going on. It's kind of weird. So one of the...
Oh, sorry, I just
ahead.
had a suggestion. Maybe if they're using the wrong email, like not the student email. I don't know.
Yeah, Grace, thank you. That's true. Yeah, because I do need you guys to be using the ames.edu email address. I think we talked about this last time that, we want to make sure we only keep it within the Ames system. So try that, Alexis, if for any reason you may be on your personal email instead of the school email. Didn't even think about that. Thank you, Grace. Okay, guys, so look at the formula over here. This is what we need to be using to calculate these probabilities. Because, you know, of course, when we're talking about, and Grace, I'm just looking at your number of heads here. So you have 6, 6, and 7. So we know the probability of landing on each head is 1/2, but we want to know what are the probability that out of the 0 to 10 heads that are possible with this experiment, what's the probability that, you know, we're going to get 6 heads out of, you know, all of those possibilities here. So this is the formula here. You're actually using, if you remember, there's the permutation and combination calculations we do if you've done that, you know, in a previous algebra course. So this is actually the NCX is actually the combination notation. So we are doing a combination between the variables of N and X. Remember, N represents the number of trials and X represents the number of successes, which in our case would be the number of heads. Then we multiply it with the probability to the power of X, and that p-value is, of course, the probability of success for each trial. So that's the 0.5. And then the last part is in parentheses 1 minus p, which, you know, 1 minus 0.5 would still be 0.5 raised to the power of n minus x. So I've shown you an example over here of how we would do this. There's 10C3 for the combination calculation, then you multiply with 0.5 to the third power, and then 0.5 to 10 minus 3. And you know that 10 minus 3 should actually also be in parentheses. So let me show you with the Desmos calculator. So I just went to desmos.com, and then under the math tools, we can select the scientific calculator. And if you go under, I believe it should be function, you will see we have that NCR. We're using X instead of R, but you know, obviously this is the combination calculator we're using. So we have number of heads, which is 3. Sorry, oh lordy. Number of trials, which is 10, and the number of success or number of heads is 3. So you can see that number comes out to be 120. And I am actually just showing you the example that I have over here. So this, you know, example is what I'm showing you how that calculation works. Then you are multiplying this with 0.5 raised to the third power. So we need to go back to the main menu for that. And you will see I'm going to use the A to the B notation. And so my number of heads is 3 again. And I'm going to multiply this with 0.5, raise it to the exponent again, and you can actually do 10 minus 3 in parentheses if you want, or, you know, just type in 7. But this is what that probability for number 3 comes out to be. And then, you know, I'm going to use copy paste to bring that in here. So I guess I'm just going to go ahead and erase this and put that number in here. And I think I have these rounded to 5 decimal places. If you go back to the handout over here. Yeah, see right over here, I'm telling you round all answers to 5 decimal places. So I think I might have set that as a default over here, but that's kind of how you do this. If you're using a handheld calculator, then you will find under maybe one of the math options, you will find the NPR and the NCR keys, you know, so I'm trying to see. Okay, so if you have one of these calculators. So under one of these calculators, the TI 30X2S, let's open this in a new. Oh, okay, I was hoping for it to be a bit bigger. It's actually under the probability option that you will find it. So if you go under probability, you will see the first one's going to be NPR, the other one's going to be NCR. So in these calculators, that's where it's going to be. In a graphing calculator, I believe you have to first go under a math option to be able to get to, you know, one of these permutation combination formulas, or, you know, go to desmos.com and use this one. So, you know, try working through the number of heads that you have. I guess those of you who have 3 heads as part of your number of success, you guys can go ahead and use the value I came up with. But then for the other ones, you know, go ahead and calculate and see what your probability is coming out to be. So Cody, I'm looking at your answer. Looks like you've already got your 8 in there. And I'll stop sharing my screen again, because just in case you have trouble, you know, going back and typing in when I'm sharing, I wouldn't want you to do that. So let's see what you guys can come up with for your probabilities here. But be careful, because, you know, the n value will stay the same, but that x value is going to keep changing. And while you guys are working on this, let me do something really quickly. I did forget to mention, you do actually have the combination function in Excel and Google Sheets also. If any of you want to use, you know, Google or Excel to do the calculation for you, you can actually do that. Let me see, is it going to be? I think it's going to be the combin function, combine. And just to verify, let's do 10 comma 3. Multiply that with 0.5 raised to the 3rd power. Multiply that with 1 minus 0.5. Raise that to 10 minus 3. Yeah, so it's the combin built-in function. Okay, so looks like most of you guys are done. I can see Cody, you've got all 3 of your values in there. Victoria. Okay, I'm looking at Ben. Okay. Ben, you should definitely not be going to 1.8 because remember, probabilities have to be between 0 and 1 because 0 means there's no chance, that event or that, that event or that outcome will happen. And 1 means, you have 100% certainty that it's going to happen. So your probability has to stay between 0 and 1. So with that 1.875, I would say go back and check your calculation on that. And your number 5, number of heads, that probability is too high. Also because you're close to being 1, with that 0.98. So yeah, if you would go back and check your calculations. Faith, I'm looking at yours. And that's interesting. For 5 and 6, you have the same probability. And Brooke, you have the same thing, and then you had 3. Samuel, you had 4, 6, and 7. You're 4 and 6. Are 4, 5, and 6 the same, or is this a rounding thing? And then Grace, for 7, you had the 0.11719, and then why do your 2 6s have 2 different probabilities? Is that just a typing error?
I keep trying to type in, like when you click on the like the cell, it says 8, but when you go off of it, it says 1. So I don't know what's going on there.
Okay. Alrighty, so I'm seeing most of you are in there finishing up. Bethany, Sky, I see you guys typing in. Hillary. All right, so you will see at the very bottom, I don't know if it came through for you guys or not. I created just a general table to kind of show you, what the different probabilities for the number of heads would be. And I just kind of started in with the 0 probability. Alexis, what were your heads? Just tell me how many heads you had in the 3 experiments. Because your probabilities came out to be 0.20508. So I'm curious to see what your number of heads look like. And I'm going to go ahead and share my screen here, guys. So right at the bottom of, where you guys typed in your number of heads, I just created this table here from 0 to 10. So I could kind of show you what this probability distribution table ends up looking like. And you know what I did here, if you look at the formula right over here, I use that combination built-in function, so COMBIN, and then I put in my 10. And instead of the number of heads for 0, again, you'll see I actually just clicked on the cell where I have typed in that 0. So the A32 cell, and then I did 0.5, which is P raised to X. Again, my X value was the number of heads, so that's that cell number again. And then I did 1 minus P, so 1 minus 0.5 raised to the power of N minus X, so again, 10 minus 0, or the cell A32. So I did that. And now I can just go ahead, move my mouse to the bottom right corner of that cell, drag it down, and it will do the calculation for all 10 of our cells over here. And then let's convert this to 5 decimal places. So that's 1, 2, 3, 4, 5, 6. One more. Okay, there we go. Okay, so you had, Alexis, 5 heads, 6 on the second experiment, and 5 for the last one. So 5, 6, 5 is what you had. Okay. So as you will see, some of you actually had the incorrect calculation for 5 because some of you had 0.20508, but 5 is where you should actually have 0.24609. So, you know, even a little typing error can cause an issue. And then you will see there's actually symmetry in this binomial distribution table. So you've got the 5, you know, which is the 24609, but then look at number of heads for 4 and 6. You have the same probability. The number of heads for 3 and 7, and one of you actually had that. Let me see if I can. 3 and 7. Who had 3 and 7? I just saw somebody. Okay. I know, Samuel, you have 7, but I thought one of you had both 3 heads and 7 heads. I guess I was looking at 2 different results. Grace, you've got 7 in there. Ben, you had 7 in there, but nobody had 3 and 7. Okay. I guess I was mistaken. Okay. Getting that aligned is not working out like I wanted to. Okay, there we go. Okay, so same thing you will notice with the 2 heads. And 8 heads, right? You will see that same probability with the 1 and the 9. So it's really interesting how this binomial probability distribution for your coin flip comes out to be, and then 0 heads and 10 heads, because, you know, it makes sense. 0 heads technically means you have all 10 tails. And, you know, obviously 10 heads. So it's either all 10 heads or all 10 tails. You will have the same probability because remember, each individual trial has the same probability of 0.5. You know, if we say 1 heads, well, that's the same thing as 9 heads, because 1 heads can compare to, you know, when we say 9 heads, technically that's 1 tail, right? So 1 head and 1 tail will have the same probability. 2 heads, 2 tails will have the same probability. So that's why 2 heads and 8 heads have the same probability. So it's really very interesting how, you know, this binomial probability distribution table comes out to be. Now, if you compare this with your binomial distribution table, and I'm going to try and see, you know, we had 10 trials in each one of them. I guess I'll need to clear this out. So we have 10 trials in each one of them. And you can see this is my 10 trials. My number of success goes from 0 to 10, just like I showed you in that. And then our probability was 0.5. And I'll need to scroll up for that. You can see 0.5 is right over here in this line. Right over, and you know, they're only going to 3 decimal places, but you will still see for number 5, we are at 0.246, and then look at those similarities, you know, on those probabilities. So just you are able to compare that and see, yeah, my probabilities are looking good. You know, they match what I came up with my, where is, with this one over here. So, you know, if you rounded these down to 3 decimal places like you have in your table over here, you will be able to make that match. Let me see if I can bring these guys on the same screen here. So right over here. So that's how you know, if you did your calculations correctly or not, or if you made a mistake. It's very easy to just use that binomial distribution table and, find your answers that you come up with. So you will have homework problems, based off of this. Obviously your experiments will keep changing, your probabilities will keep changing, but hopefully this will give you an idea of how you are supposed to use the formula to come up with your binomial probability distribution. And then, of course, you have access to the table. The only problem with the table is, look at those probabilities. You only have a restricted amount of probabilities that you can use over here. So you are, if you don't have 0.5, 0.1, 0.2, 0.25, any of these given numbers here, then your binomial distribution table is not going to be useful. So in that situation is where you use the formula. So kind of keep that in mind as you are working through these experiments and, this homework section. So the beginning part is pretty much done for you. We've created the probability distribution table. This was on that second page that we were just working on. So, what you're doing over here. Did the probabilities, match from the table to the formula? Give your answer so that you already saw that they do match. So at this point, what you guys are working on your own time is actually going to be using these two different formulas from section 6.1 and 6.2. And you will try and see, do your mean and standard deviation match. So this notation over here is mu sub x. Now remember, mu represents mean. The sub x is because you're working with the random variable x, which is your number of heads. So that's where this mu sub x is coming from, but this is basically a mean calculation. This one here is your standard deviation calculation. So that's from 6.1, and then this second formula is coming from section 6.2. So again, mu sub x and sigma sub x. So then you will compare your answers for the mean and standard deviation from parts A and B, and you will see, again, what do those answers look like? Should they match? Should they not match? And that kind of thing. So you are again turning in either an Excel or a Google Sheet. With this, you will see there's no Flipgrid with this. So you will be typing in your conclusions. If you want to type them in Excel or Google Sheets, you can do that. If you want to type them in Word or Google Docs separately, you can do that. If you want to write it down by hand and scan your paper and submit that, you can do that also. Just don't take photographs, because a lot of times the photographs do not download clearly at my end. So I have trouble seeing what you guys are writing. So scanning works better. There's a couple different scanning apps. If you guys have an iPhone, then remember under notes, you can scan from the notes feature, or I think there's, is it Cute PDF? It's one of those scanning apps that you can download. And if none of those work, send me an email and let me know what options you have available, and we can talk about it, because I know everybody has a different availability at your end. So I would like it to make it easy for you. But if you don't have any of these options available, let me know and we can try and find a solution to your problem. So remember, guys, this is due on Saturday by midnight. And you guys have been amazing about turning in assignments before the due date. And I really like that, because a lot of times, Saturday, I will look through, because I get a notification every time a submission is made. And so I will make sure, okay, you sent in. I was like, oh, that person hasn't sent in their submission yet. So I always keep worrying about, oh, don't miss your deadline. So, I'm glad that a lot of you send in your assignments earlier. So I know that, you have your submission and you are taken care of. So any questions, guys, as we kind of work through this example over here? Anything that popped up in your head? Okay. So like I said, a big part of the assignment is done. At this point, you're just finishing up those mean and standard deviation calculations, and then making those comparisons, putting in your observations, your reasons, and then pretty much submitting it at the end of that. And then you're finishing up your discussion post tomorrow. I've already received a couple emails from you requesting your password, but if you haven't done that yet, just please make sure you quickly send in your request for a password so we can get those out. Try and do that before Friday, because weekends again sometimes get challenging. And I know Sunday is Super Bowl Sunday, so if you guys are going to be busy with that, then I don't want you to have to worry about passwords and stuff on the weekend. So just go ahead and send a quick line saying, hey, Mr. Ruka, can I get my password? And that way you're done. And then whenever you're ready to take that chapters 5 and 6 exam, you already have the password with you. Okay. So if you have any questions, guys, stick around and I'll be happy to answer them. And if not, I will see you next week. Be careful, guys. Be safe. Enjoy the Super Bowl and take care of yourselves. Bye, everyone. Be careful. Take care. Bye-bye. Hello.
Hi.